Back where we started off at. So you should have finished part C. First thing you had to do was identify a GCF. So the GCF here is 2. So when you factor out the 2, you're left with x squared plus 4y squared. So now we can take what's inside those parentheses and we can factor those because we see that what's inside the parentheses, that is a sum of squares. We have that formula for sum of squares earlier in our notes. So let's use sum of squares. Let's look at this first term, the x squared. It's really a 1x squared. And then this is the 4y squared. We can take the square root of both 1 and 4. Both of those are perfect squares. So just leave that 2 out in front. So we take the square root of 1, we get 1. Square root of 4, we get 2. So 2 stays out in front, and we have 1x plus 2y, I, and then 1x minus 2y, I. Notice the 2's get the y because that was square root of 4y squared. The 2's also get the I. And it's a little bit more apparent why they get the I when we check, when we multiply them back together. The reason is because when you multiply the I times the I, you get an I squared, which is negative 1. We have 2 times negative 2, which is a negative 4, but it's negative 4 times negative 1. That's how we get back to that positive 4. So make sure you check, and then we will do part D. Let's do part D together. Now, this is one of the harder problems, so just bear with me as I go through it. So this first check for GCF, there isn't one besides 1, and GCF 1 doesn't help us. Notice this is still that sum of squares problem. Now, you may be tempted to say, well, we can't take the square root of 3 and square root of 20. Well, that's right. They're not perfect squares, but we can still take the square root of them and just write square root. So square root of 3 will just be square root of 3. Square root of 20 will just be square root of 20. Okay, and notice we had an x with the square root of 3, and we'll have the y with that square root of 20. So we write the first term, which is square root of 3 times x, and then plus square root of 20 times y, and remember it also gets the I. So again, these are some of the harder ones, just bear with me. So then we have square root of 3 times x minus, because these have to be alternating signs or complex conjugates, square root of 20 times y times I. So that would be our final. Now you could write it a few different ways, like order, so it's a little bit less confusing. So you could write this as x square root of 3 plus y square root of 20 I. Like it doesn't really matter the order as long as they're grouped together. Root of 20 and then I. But either way you write them, this is your final answer. Now, with these complex factors, we would not, in this problem, we would not find x or y. We can't really solve. This would just be our final answer. Either of these would be right. Again, these are some of the harder ones. So I want you to try one. Now, you're not going to try one with the square roots. You're going to try one a little bit easier, kind of similar to part C that you just did. So let's turn the page. We're on page 133. So I want you to try to factor 81x squared plus 64. Make sure to check for a GCF first and then factor. You will get two complex conjugates. This is a sum of squares. Okay, let's just quickly check. It was sum of squares. There was no GCF other than 1, but 1 never helps. So we take the square root of the first term, square root of the last term. So this first term does have an x squared. So when we take the square root of 81, we do get 9. But remember, there is an x with it. So when we write the factors, we need to make sure we have that x with the 9. Square root of 64 is just 8. There's no additional variable with that, so we just have the 8. But because we have those alternating signs, notice if we just left it as positive 8, negative 8, that would be a negative 64. Well, our original problem has a positive 64. So that's why you have to include those i's, because when we multiply those together, I and I is an I squared, which would end up changing this negative 64 to a positive. So let's look at number 4. Let's make sure that we really understand the difference of squares versus sum of squares. So difference of squares was the method we would use and we talked about when we were just factoring quadratics with real answers. Notice there's no I here. But sum of squares is what we're doing today. We do get those I terms. So what are some similarities that you see between sum and difference of squares? Now that you've looked at the similarities, what are some differences of sum and difference of squares? So a few things that you might have noted in the similarities is that they're dealing with A's and B's. They're both squared. So we're only dealing with those perfect squares. Some differences would obviously be like one's difference, one's sum. So those are just a few things you could have said and answered. So now that we've practiced with factoring, let's go just a step further and find x values. So let's start with this problem. 9x squared plus 16 equals 0. We would check for GCF first. There isn't one, so we're going to speed by that step. Now take the square root of the first term, square root of the last term. So we have square root of 9x squared, square root of 16. So square root of 9x squared, square root of 9, 3. Square root of x squared is just x, so that's a 3x. Square root of 16 is 4. So notice this one's done for you in your book. So with the 3x and the 4, that's how we got 3x plus 4i, 3x minus 4i. If you want to check that, you could FOIL or do the box method. You get what you started with. But we don't just want the factors anymore. We now want to actually solve. Remember, solving means you should have x equals. So just like what we did in previous lessons, whenever we had factors, set them equal to 0, solve for x. So right here I have one of the factors equal to 0. So we want to get this x by itself. So just like this 4i, treat it like a constant. Move it over to the other side. It's positive, so we do the opposite, negative. So now I have 3x equals negative 4i. Undo that multiplication by division. So you have negative 4i over 3. That's one of your x values. You do similar steps over here, but your final answer is a positive 4i over 3. Notice that's how you get two answers. We know there should be two answers because this is a quadratic. It's raised to that power of 2. So let's look at one that we need to fill in. So we have x squared plus 81 equals 0. This is a sum of squares. They're being added together. So let's look at the first term, which is a 1x squared. The last term is an 81. So we're going to take the square root of 1x squared, which is just 1x. We'll take the square root of 81, which is a 9. So that means our factors are going to be a 1x, I'm just going to put x, plus 9i, then an x minus 9i. So those would be the factors. So now what we can do is we can take those factors and set them each equal to 0. So over here on the side, we have x plus 9i equals 0. So we want to get x by itself. So we need to move this 9i term to the other side. So we have to do the opposite. Subtract 9i. Just take the I with it. So x equals negative 9i. So right here, the zero product property is basically just saying set the factor, or factors in this case, equal to 0. We have x plus 9i equals 0, x minus 9i equals 0. Now over here, we're just solving for x. So we get two x values. We get that x equals a positive 9i and x equals a negative 9i. Okay, let's look at a few more examples. You're going to help me solve this one as we go. So let's look. We have 100x squared plus 49. Your first step should be a GCF. Is there a GCF? Notice this is a sum of two squares, so we need to take the square root of the first term and the last term. So what is the square root of 100? Now what is the square root of 49? Now what do our two factors need to be? Now that we have the factors, I want you to take those factors, set them equal to 0, and solve for x.